Welcome back. Today we're going to look at just some logarithmic properties to help us solve logarithmic equations. So we're going to take a look on this first page of the four properties that we're going to use. Actually, there's just three. Number 4 you only will need if you have an older calculator. So let's start with this product rule for logarithms. So the rule says that if you have two logs being added, which remember, those are the exponents, right? Logs are exponents. And if you were adding the logs in a problem, that meant the problem was an actual multiplication problem, okay? So just to kind of remind you, if I was doing x squared times x cubed, the rule when you multiply was to add the exponents, okay? So this would be x to the 6th. So what the property says is that if you're adding the exponents, right, that's what the logs are, then that's the same thing as if you were multiplying the problem together. So that's kind of what this property says. So that just goes in line with what we used to do for exponents. So remember, we're going backwards, or we're writing this in a different form. So I know there's a lot of stuff over here on the right, for example, but the big example I want you to see is that over here you've got two logs with the same base that are being added. So we can condense that down to one log where you multiply the answers together, okay? So logs that are being added, you condense by multiplying. That's what that product says. So the same thing is true for division, okay? Remember when you were dividing, let's say this, when the problem was division, you ended up subtracting the exponents. So this was what the quotient rule says, is that if you're subtracting exponents, then the problem had to start off as a division problem. So that's how you're going to condense it, okay? So look at the example again. You have two logs together that are subtracted. So remember, to do the property, each log that's being added or subtracted has to have a log with it, okay? So as long as that's true, then you can condense it down to one log being multiplied, and down here, one log you're going to divide. So 16 divided by 8 is 2, okay? And again, that's the rule for the exponents. All right, the last rule is the power rule. So when you're raising a log to another power, you're going to multiply that power times the log. And again, that goes down to our property when you raised a power to another power, okay, that you multiply those together. So that's what this says. When you have one power, the log is its own exponent, raised to another power, you multiply them together. Okay, so usually for this, most of you guys just remember that you're taking the exponent and it goes out to the front of the log. Okay, all right, so if you look at this example, log base 2, 4 cubed, I can bring the 3 out front, and that's the same as 3 times the log base 2 of 4. Okay, so that's what that property says there. And this keeps going to simplify it, which we'll do in a little bit. All right, the last formula is this change of base formula. We'll get to that at the back of this, the notes, and I'll talk to you about this, but we only need this if you don't have the newer version of the calculator. So if you have the new version of the calculator, you're not going to need this, okay? But what this property says, if you do need it, is if you're taking the log of a different base that you can't use, your log button on the calculator, then you're going to switch this to base 10, common log, so that you can use your calculator. So you would always take the log of the big number, the answer, and you always divide it by the log of the base, okay? So we'll talk about that on those last few problems today. So what we're going to do with the properties is we're either going to expand them or we're going to condense them, okay? That's your job. That's what you'd have to be able to do. So we're going to start with example 1, which is expanding. So you're going to take one log and you're going to break it up either using addition if it's multiplied, subtraction if you see division, or the power product rule if you see an exponent. All right, so let's start with A. Log base 5 of 12 divided by x. So now we're looking at it from this perspective. So I'm giving you this and we're expanding to this. So we're going backwards sort of from the rule. Okay, so we want to expand. So when you have the log being divided, you can break that up into the top, always the top, and then minus the log of the bottom. So again, 2 logs being subtracted is the same thing as 1 log being divided. Okay. All right. So now we have 25 times x cubed. So since that's a product, we're going to break this up by adding. So the log of the first plus the log of the second. Okay, so we'd almost be done, except the only problem is that we have an exponent. So a log raised to an exponent, we're supposed to bring that exponent out front. So I could go one more step, log base 5 of 25 plus 3 log base 5 of x. Okay, so I just bring the 3 out front. Now, any log that's just a number, you need to see if it has a simplified answer. If it's a decimal answer, you leave it like this. But if it's a whole number, you need to reduce it. So 5 to what power is 25? That's a doable log. That is 2, right? The exponent is 2. So the condensed or the expanded version of this would end up being that. So again, if you have a log of a number, you need to see if you can simplify it to a whole number. All right, moving on to part C. Division. So we're going to break up the division by subtraction. So we'll have the natural log of the square root of x minus the natural log of e to the x. All right, this is x to the 1/2. So let's try to make my L's look like L's. Okay, so now you have the exponent of 1/2 that has to come out front. So this is 1/2 the natural log of x minus the natural log of e to the x. All right, remember, this is log base e, right? So remember, that's that property when you have the same base and that same base, they cancel out and leaves you x. So this could be simplified down to just x, right? Remember, e to what power gives you e to the x? That would be x. So that's the same base. So that would be the simplified version of that. All right, the last one to expand. We're going to start always with the division. So let's break that up. Log of x plus 1 to the 6th minus log of y to the 4th square root of w cubed. Okay, so that would be the first thing we're breaking up. Now I've got multiplication here, so I need to break that up. Excuse me. And as I break it up, I'm going to write this in exponential, this radical in a rational fraction. So it would be 3/2, right? The square root is a 2 here. All right, so let's look at that. So I've got the log of x plus 1 to the 6th minus log of y to the 4th plus log w to the 3/2. Okay. Now, why did I put brackets around there? Because remember, both of these are in the denominator. So both of them have to have a minus sign in front of them to get them down there. But together, they're being multiplied. Okay. So once I simplify, I'm going to bring this minus sign through both. So both of these will have a minus. Now, this x plus 1 is just one term, okay? So you can't break that up anymore. Remember, for addition or subtraction, you have to have a log for each to condense it to multiplying. So this can't be done, and this is already simplified. So all I can do is bring the 6 out front of that log, okay? Minus, I can bring the 4 out front of this log, and I can bring the 3/2 in front of that log. Okay, and I distributed the minus sign through both of those. So when you're looking at this, when you see minus signs in front of logs, that means they will end up in the denominator, and any positive log will end up in the numerator. Okay, that's kind of what your plus and minuses are telling you. The minus sign has nothing to do with the exponent. Your exponents are always going to be positive. Okay, when you bring that 4 back up, that doesn't come with it. That just tells you whether you're adding or subtracting, whether it's in the top or in the bottom. Okay? All right, so that's it for that one. That's an expanded form. All right, so now we're going to go the other way, which is to condense. Okay, so we're going to do things opposite. So the first thing we're going to do to condense is think about what we did here. I'm going to take any number out front, put it back. Then I will combine multiplying or dividing based on the signs out front. So the first thing I'm going to do is move this 1/2 back as the exponent and move this 3 as the exponent of z. Okay, so that would be the log of x minus 1 to the 1/2 power minus the log of z to the 3rd power plus log of 5. Now remember, this is the square root. So my next step, I'm going to write the square root of x minus 1 instead of that. And so your positive logs are multiplied together, will be in the numerator. Any negative log means it was divided, so that will go in the denominator. So now I can condense down to 1 log. So 5 times the square root of x minus 1 will be in the numerator, and z cubed will be in the denominator. Okay, so let's think about that. Okay, so if I were to break this up, I'd have the log of 5 plus the log of this. So that's those two. And then I'd have minus the log of this, which is that one. Now you could have wrote the square root of x minus 1 and then times 5 at the back. I just put the 5 in the front. That's the typical way we write it. Okay, so they don't have to be in the same order here. It's just the right way to correctly write that. All right, look at the last one in B. So this 1/3 is out front. Okay, so that I got to distribute that. So this is 1/3 the log base 3 of x. 1/3 times that -2 would be -2/3 log base 3 of y, and then plus log base 3 of 10. All right, so now this is the exponent that'll go up here. This is the exponent that'll go there. So log base 3 of x to the 1/3 minus log base 3 of y to the 2/3 plus log base 3 of 10. All right, so remember your roots. So when we condense now, this is going to be the cube root of x, and this will be the cube root of y squared. Okay, so let me write those over here. So x to the 1/3 is the same thing as the cube root of x, and y to the 2/3 is the same thing as the cube root of y squared. Okay, remember your numerator is your exponent and the denominator is the root, right? Okay, so look at your positive things again. Positive, these are the top, that'll be multiplied together. This will be in the bottom because of the minus. So we can condense it down to 1 log, 10 times the cube root of x over the cube root of y squared. Okay, so that's your 1 log condensing down. Okay. All right, so the properties are not hard. You just got to remember, you divide when you see subtraction and when you multiply when you see positive logs, okay? All right, so now we're going to evaluate. So this, again, when you're evaluating, you want to try to condense as much as possible, okay? So let's look at, I feel like that's a little blurry. Hang on a minute. Let me try to autofocus this a little bit more. Okay, that looks a little better. All right, so the first thing we're doing when we're condensing is get the exponent back up. So that 2 is the exponent for 3. So 3 squared is 9. Okay, so I got to move that 2 back where it belonged. Now I have 2 logs being added, so that means I multiply that together. So this is log base 6 of 36. And now this is asking me to find the exponent. 6 to what power is 36? That would be 6 squared. Okay? All right. Exponent is going to come back up here. So this is the natural log of e to the 8th minus the natural log of e to the, so we multiply, so that would be 20. Okay. All right. Now, the natural log, remember, the base is e, right? The base is e, it's understood to be there. So e to what power is e to the 8th? That just simplifies to 8. And e to what power is e to the 20th? That reduces down to 20. So now all I have is 8 minus 20. So the answer is negative 12. Okay? All right. Okay, so the last thing is to talk about the change of base formula. So let's talk about your calculators. So get your calculators out, take a look at them. If you have the newer version, okay, then you have some new functions that are listed under your function keys, which are the green keys right here, F1, F2, F3, right? See that? So if you have the new version, you should be able to hit alpha for F2, so hit alpha window, and you would get this list of options for your new functions on the calculator. And there's a bunch of them, but it should come right up here to function, and you should see this list of 5, and number 5, if you have it, press it, you'll get this notation, log base. So I can put this in my calculator just like that. Put in the 4, put in the 17, okay? So if you have that, then you do not need the change of base formula. So if you're asked to use the change of base formula, you don't need to do it. You have the capability of doing all logs in your calculator. So we'll hit that answer, and we get 2.0437. Just round it out to there. Okay. All right, now, if you don't have that, if you have an older calculator, then you do need the change of base formula, because the only log button you have on the older calculators is this one, but this is a common log base 10. So the change of base formula says, take the log of the bigger number, the top number, and divide it by the log of the base. Okay, always. Log of this big number and always divide it by the log of the base. If you do that now, if you don't have what I just showed you, we're going to use the log button. Okay, so I'm going to do the log button, LOG button of 17, close your parentheses, and then divided by, then hit the log button again, and this time you'll put 4. Okay, so that's what I have on my paper, and you'll see you'll get the same answer. Okay, so all of you can do this on your calculators, whichever calculator you have. So either you have the new version, that's alpha F2, or you'll do the change of base formula. All right, so if you're going to do the change of base formula for B, log of 10 divided by the log of 0.05. And if you are going to do number 6, I need to get rid of, I can do the 6, so 6 times. Okay. And then you would do the log of 11 over the log of 3. If you have the new calculator, you just put it in just like it is. So let's do B. I'm going to do alpha F2, number 5, and I will put in 0.5 for my, let me get rid of that, start that again. Talking and doing too much at one time, so 0.5 is the base, and then 10, okay? So either way will get you negative 3.322, round it. And the last one I would do 6. Well, actually on the last one I would just put in the log base 3 of 11 just to be on the safe side. So I would do log base 3 of 11, and I would get that answer, and then I would multiply that by 6. I just like to do fewer things at one time. Makes me a little bit, I feel better about that. So 096. Okay. So again, if you didn't have the change of base or didn't have the new version of your calculator, I would have done the log of 11, okay, divided by the log of 3. I would have hit enter, and then I would have multiplied that by 6. That's how I would do that. Okay? All right, so there you have your 4 new properties, and again, that 4th one only if you need it. So work on your homework. Make sure you're okay with these rules, expanding and condensing, and let me know if you have any questions.